Right. All right, everyone, let's go and do some more examples with regards to power. Okay, let's practice some more. The more we practice, the better we become at the section. Okay, it's a relatively easy and small section. Okay, so if we can score marks in it in the exam, then we know, okay, this section is covered. All right, so let's have a look at question 3. Now, question 3 reads, Jack and Jill ran up the hill. Jack is twice as massive as Jill, yet Jill ascended the same distance in half the time. Who did the most work? And who delivered the most power? And we can explain our answers. Okay. So now, again, how do we approach this question? They said that they both ran up the hill. They said that Jack is twice as massive as Jill. Alright, so that means that the mass of Jack is double that of the mass of Jill. Alright, they double that. Okay, what else did they say in the question? Jill ascended the same distance in half the time. So, half the time that Jack took to get up the hill is what Jill took. Alright? So Jill ascended half the time as what Jack took to get up the hill. Alright? Then they ask us who did the most work and who delivered the most power. Alright, so we can further explain this quickly, that therefore the time that Jack took to get up the hill, alright, Jill went twice as fast. Alright, perfect. Now who did the most work and who did the most power? So the work done here was to increase the gravitational potential energy of the system, okay, because they're running up the hill. So let's assume, okay, in the corner here, let's assume that the hill has a height of h. Okay, then therefore the work that Jill did is equivalent to the mass of Jill times gravity times the height of the hill, and the work of Jack is equal to the mass of Jack, alright, times the gravity times the height of the hill. Okay, now what can we see here? We know that the mass of Jack is twice that of Jill's mass. So we can sub that in the formula. So therefore the W, or work that Jack did to get up the hill, is equal to 2 times the mass of Jill times gravity times height. Alright? What else can we see? Alright, what else can we see? Alright? We can take 2 out of that formula, and we can write it closer to the margin to have more space. The W of Jack is equal to 2 times the mass of Jill times gravity times height. And we know that, or we can see that this is the same as that. So therefore, the work that Jack did to get up the hill is equivalent to twice that of the work Jill put in to get up the hill. Alright, so there's our work equation. Now let's compare power. Okay, let's put power in on this side of the margin. Okay, there we go. Let's compare power. Oh my gosh. There we go. Power we know is equal to W over T. Alright? Alright? So we know that the power of Jill, okay, and I'm just going to Alright, so we know that the power of Jill is equivalent to the work of Jill all over the time Jill took to get up the hill. And we know that, let's put Jill there quickly, and we know that the power of Jack, alright, is equal to the work that Jack put in, alright, all over the time that Jack put in, alright, to get up the hill. Now, what do we have? We know that the time, the work of Jack is equals to twice that of Jill, and we also know that T of Jack is equal to twice that of Jill as well. Okay, so we can sub in there actually. So then this is going to equal, we know the work of Jack is twice times the work of Jill, so 2 times the work of Jill, alright, over 2 times the time of Jill. Alright, we know the 2's are going to cancel out, so P of Jack is equal to W Jill, Jill's work, all over her time. Alright, and we know that this is equal to P of Jack is therefore equal to the power of Jill. So the power of Jack, therefore, is equal to the power of Jill as well. Okay, so the power outage are the same. Okay, so I'm going to make some space here by erasing a line out of my margin. Alright, and then I'm going to draw a line across here. Keep that information there. Alright, so we can therefore see, okay, that the power that the 2, alright, had the same power to get up the hill. The same power to get up the hill, but Jack did twice as much work as Jill. Alright, we can see that from our calculations. Okay, so it's very important when we have questions like that to do what I've done here. Okay, is to put the words into what they've told us into formula. Okay, they told us that Jack was twice that of Jill's mass. He was twice as massive as Jill. Jill took half the time to ascend the hill as what Jack did. Okay, so she accelerated, or not accelerated, but she went up the hill twice as fast as what Jack did. Okay, and then once we have that, we know our formula for work is W over T. Okay, well, that's for power. Sorry, we know formula for power. We also know that work, the only work here is to increase the gravitational potential energy. Okay, and which is FGH. And then once we put those into perspective, we can see, okay, that Jack had to do twice the amount of work as Jill did, okay, and also but they both use the same amount of power to get themselves, or to power themselves up the hill. Okay, so that was a nice question, nice interesting question. Okay, in the next video we're going to do question 4.